correlation, partial or multiple correlations. The next one is positive and negative correlation. The third one is perfect and imperfect correlation. Last one is linear and non-linear correlations. So these are the different type of correlation. Moving to the next one. If you go to the first one, in case of simple correlations, when the relation between any two or only two variable is studied, that is known as simple correlation. For example, in case of if you study the correlation between height and weight or price and demand, this directly goes to simple correlations. Moving to the next one, that is known as your partial correlations, when the relation between any two out of three or more variable is studied. Suppose you have 5 number of variable, out of 5 one number of variable, you go for calculating the partial correlation. In that case, you have to choose only two variables, which is no, or ignoring the effect of other related variable. It is called partial correlations. Moving to the last one, that is known as multiple correlations, when the relationship between any three or more variable is studied at a time, it is called multiple correlation. I'll show some example in case of statistics. If you go to the first one, is it visible to all?
Yes, sir.
Yes, sir.
Okay. In case of your simple correlations, the basic example when it is done between demand and supply, or we can say that is income or expenditure, it is known as simple correlation. But in case of partial correlations, the analysis is done with the demand, supply, and income. In that case, income is kept constant, and you can directly study about demand and supply. Similarly, if you go to the correlation in case of multiple correlationship, in that particular correlation analysis, for example, in case of rainfall or production of rice, and in case of price of rice are studied simultaneously or at a time, and it will be known as multiple correlations. So these are the few examples which is basically used in case of your business as well as in case of your financial analysis. Moving to the next one is positive and negative correlations. In case of positive and negative correlation, first one is positive correlations when the value of both the variable under the study and it move in the same direction. I repeat, in case of positive correlation, when the value of both variable under study and move in same direction, that is with increase in value of one variable, and you can say the other value will also increase. Similarly, if one variable is decreased or value of one variable is decreased, the other will also decrease, and this is known as positive correlations. Then moving to the next one, that is known as negative correlations. In case of negative correlations, so when the value of both variable under the study and move in opposite directions, with the increase of value of one variable, that means another variable should be decreased. Similarly, if you consider if one variable has decreased and followed by the another one is increased. So basically, in case of positive and negative correlation, that should be presented or that should be represented by a scatter diagram. That means, suppose you have the expenditure, and in case of x-axis you have the financial expenditure is there. In case of y-axis, the financial year is mentioned. In that case, most of the time the financial prices of different products and services that should be done through the scatter diagram. I'll show that one. If you go to the example of positive and negative correlations, here the typical example. Suppose if you go to positive correlated or positive correlations, that is pressure versus temperature. So if pressure is increased or if the temperature increase, automatically the pressure also increase. But if you go to the negative, for example, whenever you go for marks in examination or exam mark versus how much hour you spend on watching TV, in that case, these are very much negative correlation, because if you increase your marks, that means you thus decrease the percentage of hour of spending watching on TV. Similarly, if you go to the statistical point of view, if you go to the bottom of this particular slide, the example of positively correlated data, for example, in case of sales versus profit. So if you observe in case of sales, that is 5, 7, 8, that means that starting from 5 to 20, that is increase in order. Similarly, the profit also increase in that particular manner. That is 2, 4, 6, 8, 9, 10, 11, up to 15. But in case of negative correlation data, especially reference to your statistics, in that case, if the price is decreased, automatically demand will increase. Similarly, if you go to the last column, if the price is increased, the demand is very much less. And these are known as or you can say it is the negative correlated data, especially reference to your core relationship. Moving to the next one. The next type of correlation is your perfect, or the next one is imperfect correlations. If you go to the perfect correlation, when the value of both variable under the study change at a constant ratio irrespective of the direction, and it is called perfect correlation. And the value of perfect correlation will be either positive or negative. That should be range between +1 to -1 or -1 to +1. So the perfect correlation can be either of perfect positive or perfect negative in nature. If you go to that particular case, as I told, in case of most of the correlation are presented in graphical or scatter diagram by the help of, this should be represented by the help of your graph or scatter diagram. Similarly, if you go to the next one, that is known as imperfect correlation, when the value of both variable under the study change at different ratio, and it is called imperfect correlations. That means the value of imperfect correlation will be between 1. And so the perfect correlation either be imperfect positive or imperfect negative in nature. As I told that most of the cases, especially reference to your correlation, whether it should be perfect or imperfect, whether it should be negative and positive, that should be represented by the help of scatter diagram. Here the example of perfect correlations between the x variable and the y variable. And in case of the second diagram, that represent various type of scattered points, and which shows your x versus y variables in a scattered way. But if you compare perfect versus imperfect way, they rapidly provide the value, or you can say that is the value of perfect correlation will be either positive one or negative one. But in case of imperfect, the value of imperfect correlation will be between 1. That is the biggest difference between perfect and imperfect correlation. Moving to the next one. The last one is linear and non-linear correlations. So if you go to the definition of linear correlations, when the data relating to correlation is plotted on a graph paper, give rise to straight line. So whenever you go for a linear diagram of correlation, it should be, say, a straight line. In case of linear correlation, it may be positive or in negative in nature, and according it may be give either upward and downward straight lines. But in case of non-linear correlation, these are represented in the form of curve or curvilinear correlations. I just read the definition. When the data related to correlation plotted on a graph paper, which gives out a curve of any direction, that is called non-linear correlation and curvilinear correlations. If you go to the property of non-linear correlations, it may be positive or negative in nature, and accordingly it may be give either upward and downward curve when plotted on graph paper. So in case of your perfect and imperfect correlation, that should be represented by a scatter diagram. In case of positive and negative correlation, that should be represented by a graph. And in case of linear and non-linear correlation, that should be also represented by the help of graph papers. So these are the different types of correlations. Moving to the next one. If you take the example in case of linear and non-linear, here in case of x-axis that and versus your y-axis, especially in case of linear correlation, the variable represent various type of data, and that data are plotted in a graph paper in a straight line. But in case of non-linear correlations, that should be on the graph paper, and which gives a curve of any direction, whether it should be towards y-axis, whether it should be on x-axis. So if you go to the statistical point of view, in case of linear correlated data, suppose cost versus profit is there. And in that case, if the cost is range from 10 to 15, similarly the profit of that particular data should be range from 5 to 25. That directly gives a particular idea on graph paper that should be a straight line. Similarly, if you go to the non-linear correlated data, suppose that is sales versus profit, that should be range from 50 to 90. But in case of profit, that is 5 to 10. So if you plot this particular data on the graph paper, that should be provide a particular graph. Sorry, that provide a particular curve line of any direction, whether it should be x direction or y direction. So moving to the next one, the practical application of correlations. These are the applications. It is used in deriving precisely in case of degree and direction of relationship between a variable, for example, in case of price and demand, or you could say that it's advertised expenditure versus your sales. It is used to develop concept of regression analysis or ratio of variation, which help estimating the value of different type of variables. As I told, in case of price and demand or your production and employees, these are the example, especially in case of you perform regression as well as different type of variations. Then the point number 3, it reduces the range of uncertainty in case of matter of predictions. It provides a particular range of uncertainty, whether it should be a straight line or whether it should be a curvilinear correlation that should be predicted by the help of correlationship of analysis. Then point number 4, it represents the average relationship between any two variables through a single value of coefficient of correlations. Point number 3, especially in case of economics, it is used in understanding the economic behavior and locating the importance variables. In case of business, it is used to estimate the cost of sales, sales price, volume of sales, etc. But in case of science and philosophy, the method of correlation is used in making progressive development respective lines according to the plotted graph, or whether it should be a scatter diagram, whether it should be a graph plotted on the graph papers. So these are the basic applications in the various fields like economics, business, in case of science and philosophies. So apart from those things, basically it is implement for, you consider it to find out the or to develop the basic concept of regression analysis, and you consider it is calculating the different ratio of variation which help to estimate different value of variables. So moving to the next ones, the different method of simple correlations. I advise all of you just note down these methods, because we will perform some numericals starting from Karl's Pearson coefficient method, Spearman coefficient method, least square coefficient or correlation method. The last one is concurrent deviation methods. And apart from the 6, in case of diagrammatic method and graphical method, these are only theories. That is my advice. Just note down, then we'll proceed to discuss one by one. If you done, then just text a message on chat box. Is it finished? Is it finished? Anyone?
No, sir.
So Rachana Mishra is very fast. Fine. Okay. So let's start with the first method, that is diagrammatic method. Basically, this method is used a scatter diagram. It's drawn on the basis of corresponding value of any two variables. I repeat, this method is used, or under this particular method, a scatter diagram basically used to draw on the basis of corresponding value of two variables, whether one should be lie on x axis and another should be lie on y axis. So here the example are given in case of scatter diagram. In the first row, that is the degree of correlation are given in different colors, whether should be non-correlinear, low in case of correlative relationship, or the third one is high, or the last one is perfect correlationship. Similarly, if you compare the different type of correlations, that is, for example, whether it should be positive or negative, or your curve or partially correlated variables, that should be directly used you consider this particular color should be used, or pen should be used to mark on graph paper. So these are known as scatter diagrams. So basically, diagrammatics method, it is used to scatter diagram, which represent, I repeat, in case of scatter diagram, it represent two variables. One should lie on x-axis, another should lie on y-axis. Moving to the next one, that is graphic method. So in case of graphics methods, under this method, graph is drawn for each of the variable under study. Suppose if you go to the bottom of this particular slide, the number of year is given, that is starting from 95 to 2000, and the percentage of profit is given, and the value of different variables, that is 40, 55, again 45, 65, 70, and 60 is given. So these value of all variable are represented on y-axis, and the value of common reference are represented on x-axis. That means that profit belongs to the reference of that particular year, and that should be drawn on the piece of graph paper. And you can use also in case of Excel sheet to draw this particular graph. So this method are basically used for comparing the different value and their reference year and times. For example, price versus the financial year. For example, in case of production versus your number of employees of the year. So that should be directly this value or this variable are comparable in the form of graphics methods. Moving to the next ones, that is the most important things. Every year from this method, around most of the question will be appear, that is known as Karl Pearson's coefficient method. In case of Karl Pearson coefficient method, the Karl Pearson is a British biometrician. He derived the several formula for measuring the nature of correlations. And he represents the coefficient of correlation through R. I repeat, the coefficient of correlation, which is represented by R or denoted as R, and the value of this correlation is in between plus and minus 1. So it is my advice from my side, you must note the value of correlation that should be lie in between positive plus minus 1. And if you go to the chart of correlationship, for example, in case of positive plus minus 1, that represent perfect correlations. And in case of your 0, that represent no correlations. That is from my side, I direct you to note down this first one, that is positive plus minus 1. And in that case, the degree of correlation is perfect correlationship. And the last one, that is 0, represent no correlationship. So these two values are included in case of your curriculums. And the rest are for your observations. Yet finish? Is it finished? Anyone? Shall I move to the next one? Yes, okay, fine. So it is my advice that you have to write the first, that is positive, negative 1, plus minus 1, that represent perfect correlation, and the last one is 0, represent no correlation. Clear? बाकी सब काम में नहीं आएगा. First one, last one काम में आएगा. Clear? Moving to the next one. In case of Karl Pearson coefficient methods, the first type of method that is known as direct method. Just note down the formula, then we proceed to calculate an examples. As you know, we are running short of time. If you finish, just drop a text on chat box. I just read the notations of that particular formula belong to direct methods, especially reference to your Karl Pearson coefficient methods. Here R represent the correlation that equals to summation of xy divided by n into sigma x into sigma y. So here x is stand for deviation of first variable from its mean, and y stand for deviation of second variable from its mean. The next part is summation of xy, that is total of product of deviation of first and second variables, and n represents number of pairs of the variables, or you can say that is the number of observations should be stand by a. The next is sigma x, that is the standard deviation of first variable. Then proceed to the next one, that is sigma y, that is the standard variation of second variables. So if you customize or if you uh, convert the formula into other word, that is r equals to summation of xy divided by square root of summation of x square into summation of y square. Is it finished? Okay. Only two people, three. What about others? Are they finished? Okay, Sangram finished. Priti finished. Priti Ranjan, Vishwas, Sanjay, fine. So just note down the examples. Here the typical example belong to direct method. From the following statistics, find the Karl Pearson coefficient by direct method basing the deviations. So here we have x variables, that is 8, 4, 10, 2, 6. And in case of y variable, the data are 9, 11, 5, 8, 7. Just note down this data. Is it finished? Okay. Moving to the next one. So here two variable is given in the form of x and y. So before solving, you made this type of tables. The first three column belong to x variable. Then the next three column belong to your y variables. So here I write the x variable data, that is 8, 4, 10, 2, 6. Similarly, I repeat the data of y also 9, 11, 5, 8 and 7. Then the first step is you have to calculate the mean of x. That is x bar equals to summation of x divided by n. I repeat, in the first step, you have to note down you have to calculate the mean, that is x bar equals to summation of x divided by n. So what is the summation of x here? Anyone?
30.
30.
Summation of x is 30. Clear? And what is the value of n?
5.
1, 2, 3, 4, 5. Clear? I just write here the n equals to, calculate the x bar. What is the value of x bar?
6. So 6.
6, sir.
That means whenever you calculate small x, in that case, that is 8 minus, I just write here, 8 minus how much? 6. That equals to 2. Is it clear?
Yes, sir.
Next one is 4 minus your 6. That equals to how much? Minus 2.
Minus 2.
For the third row, 10 minus 6, that equals to 4. Similarly, for the next row, that is 2 minus 6, that equals to how much?
Minus 4.
Minus 4. And the last one is 6 minus 6, that equals to
0.
0. Is it clear? Then after you calculate the x square, that means first one is 4, the second one is how much? 4.
4.
Next one is
16.
16. The next one is 16, last one is 0. Okay, then after you calculate y bar. So what is the summation of y here?
40. 40.
40, sir.
Clear? And what is the value of n?
5.
5.
Exactly, value of n is 5. Calculate the y bar.
8, sir.
Yes, sir.
8.
8. That means whenever you calculate the small y, that is y is your 9. 9 minus 8, that equals to 1. Moving to the next one, that is 11 minus 8, that equals to 3. The next one is 5 minus 8. Sorry. Moving to the next one, that is 5 minus 8, that equals to minus 3. Next one is how much? 8 minus 8, that is 0. 7 minus 8, that is 7 minus 8 equals to minus 1. Then after directly go for squaring of y, that is 1. This one is 9. Next one is 9. The fourth row is 4, sorry 0. The last one is 1. Is it clear to all?
Yes, sir.
Okay. For the last column, you have to multiply small x and small y. For your observation, I made in red color. Okay, that means second column and the fifth column. That is 2 into 1. How much? So 2 into 1.
2.
2. Next one, minus 2 into 3.
Minus 6.
Minus 6. Next one, 4 into minus 3.
Minus 12.
Minus 12.
Minus 12. Next one is minus 4 into 0. That is 0. And the last one is 0 into 1. That is 0. So what is the sum of x, y?
Minus 16.
Minus 16.
Minus 6.
Minus 16. Okay. So as per the given formula of correlation, so belong to direct method, the formula is already given, sorry. Then the second step is you have to calculate the standard deviation in case of x. The formula it is already given, it is square root of summation of x square divided by n. The summation of x square, what is the sum of x square here?
40, sir.
Sum of x square is 40. Similarly, sum of y square
20, sir.
20. Calculate the values. What is the value? Anyone? Square root of 40 divided by 5.
Sir,
Sir, 2.82.
2.8. 2 root 2 or
2 root
2.82. Clear?
Yes, sir.
Similarly, calculate the sigma y value. That is summation of y is equal to your 20 divided by 5.
Sir, answer 2, sir.
Answer is 2. That is correct answer. Then in case of step number 3, you have to directly apply the collected data in case of sigma x, sigma y in the last formula, that is correlation, specially belong to direct method. R equals to summation of xy. Summation of x, what is the value of summation xy here?
Minus 16.
Minus 16, sir.
16. Minus 16 divided by 5 into, first one is 2.8 into 2. Calculate this one.
So 0.57.
Minus 0.56.
Minus 0.57. Is it clear? Let's check who have finished this one. If I extend 5 minutes more or 5 to 10 minutes more, is it okay for you from your side? Is there any problem if I extend this particular session 5 to 10 minutes more? Okay, fine. Moving to the next one. Moving to next problem. Here the problem. From the following statistic, find the Karl Pearson coefficient by the direct method basing the deviation. We have the x variable 50, 60, 55, 65, 75, again 70, 75, 80, 90, again 80. And in case of y variable, we have 10, 14, 15, 11, 12, again 15, 16, 20, 18, and 19. By using same formula, just calculate. Pratyas, what is the value of x bar in this particular problem? Pratyas Jena, Pratyas Jena already left. Pritam Palli, okay, Sangram is that is correct
70.
answer. Correct answer. Then calculate y bar.
So 15.
15, 1, 5.
Yes, sir.
Okay, it's correct. Priyaranjan Sahu,
Yes, sir.
what is the value of y bar? Priyanka Nanda, what is the value of y bar? Okay, Pritin Abali, your answer is correct. Sakshi Agrawal, Rojanil Patna, your answer is correct. Shailesh Naik, correct. Okay, moving to the step number 2, calculating the standard deviation. Soubhagya Lakshmi Singh, Shivani Jana, your answer is correct. Moving to the next one, calculating the standard deviation for x and standard deviation for y. I have already solved that one. Now just check your answer. Yes. What is the standard deviation for x? It is square root of summation of x divided by n. Similarly, in case of calculating the square root of
11.83.
correct, you just drop your answer on chat box that all of you can see and recheck their answer. And in case of calculating the standard deviation for y, that equals to square root of sum of y square divided by n. Sangram, what is the answer for standard deviation of or you can say it is sigma y?
Solving, sir, solving.
Okay, in previous class, we just quickly summarized the internal patterns. In the last 5 minutes, I will discuss regarding how you maximize your percentage in case of internal as well as in case of external. Here. Okay. In case of correlationship, what is the value of correlation? Final answer. Anyone? I'll show that particular tables clear here. If you calculate the mean of x, that is 70, that is 700 divided by 10, that equals to 70. In case of y bar, that is sum is 150 divided by 10, that equals to 15. If you apply the, if you go to the step number 2, that is standard deviation, that equals to square root of sum of x square divided by n. So here sum of x square is given 1400 divided by n is 10. Clear? Similarly, if you calculate the standard deviation of y variable, that is square root of sum of y square, that is 102 divided by 10. Is it clear? So what is the answer for correlationship?
Sir, the summation of xy will be 300.
300. Let's check. X into y, that is okay, 100. The second one is 10.
No,
Third
sir,
one is
270.
270. Use
No,
the
sir,
number.
it's 270, sir. 270.
270, that is.
No, sir, 270. Sorry, sir.
Okay. So let's discuss the important things.